All right, mathletes, here's 10.5, partial fraction decomposition, cases 3 and 4. So remember, we're dealing with rational expressions, and p is our numerator, q is our denominator. We don't want to let q to be 0. So today with cases 3 and 4, we are going to have our denominators that have irreducible quadratic factors. Case 3 is where it's non-repeating. So you could have something like p over x squared plus 1. So x squared plus 1 cannot be factored. So what we're going to do, regardless what the numerator is, what we do is, because the numerator, we're going to allow it to be a linear term. So instead of just having a variable a on the numerator, to do our partial fraction decomposition, we're going to let it be a linear term, ax plus b over x squared plus 1. We could still have a linear term here, like x minus 1, and we could add that and say, okay, there has to be a c, and there's an x minus 1 here as well, and include that in our process of solving. Case 4. Well, we have repeated irreducible. So we might have something like p over x squared plus 1, and that's squared. So it's a repeated irreducible quadratic factor. Well, we do this similar to how we dealt with case 2. We're going to have to say, all right, we have ax plus b over x squared plus 1. And then we're also going to have a linear term up top, cx plus d over the x squared plus 1 squared there. And again, it might be included with maybe a linear term like x. So that means that over here we would have to do plus a, b, c, d, e over x as well. All right, so let's see what first example of case 3 here. So write the partial fraction decomposition of the rational expression 12x plus 3. So we notice we have a linear term, x minus 1, and we have this irreducible x squared plus x plus 1. So for our linear term, x minus 1, we have x minus 1 over a. And because x squared plus x plus 1 can't be factored, I can't find things that multiply to 1, that add to 1. So then, because it's irreducible, I got to make my numerator linear. So it's going to be bx plus c. So I got to find that unknown variable in front of my x and my constant c, which is over my irreducible quadratic. Okay, so just like yesterday, what we're going to do is we're going to multiply out our denominator to both sides. So if I take that piece and I multiply it here to this entire quantity, x minus 1 times x squared plus x plus 1, well, what's going to cancel out? So the x minus 1s are going to cancel out when I distribute it to the a term. So I'm going to get a times x squared plus x plus 1 plus, and then my bx term. So my bx plus c, that numerator, the quadratic is going to cancel out, and this is going to be multiplied by x minus 1. Well, this needs to be equal to 12x plus 3. So now I'm going to start grouping things. So I'm going to try and use some colors here to help this out. Well, before I start grouping, let's go ahead and distribute this stuff through. So I'm going to get a x squared plus ax plus a plus, so here I have a double distribute because we're multiplying here. So I get bx times x, and I get bx squared minus bx plus cx minus c is equal to 12x plus 3. Okay, so then I'm going to try and group together all my a terms, or my x squared terms. So I have x squared term here, x squared term here. So I see that it's going to be a plus b, factor out my x squared there, plus, well, then my linear terms, I have an ax minus bx plus cx. So I'm going to have an a minus b plus c all times x plus, then my constant terms is a minus c. And this all has to be equal to, well, I don't have any x squared terms, so for the sake of argument, I'm going to write 0 x squared plus, and then I have 12 x, I didn't want that to be red, so that's going to be an x, and then I'm going to add that to my constant, which is 3. Okay, so now I notice I have that grouping, and now I'm going to set up my system of linear equations here. So I know that these two values have to be equal to this. So I get a plus b equals 0. My next piece is here. I get a minus b plus c equals 12. And my last piece is a minus c equals 3. All right, so I'm going to solve these by elimination. First thing I want to do is I want to eliminate a b value. So I see that if I add these two together, I'm going to eliminate my b value. So when I add those two together, I'm going to get 2a, b's cancel out, plus c, 0 plus 12 is 12. So now that I've eliminated my b from this second one, I have an AC equation here and an AC equation. If I have two unknowns, two equations, I can solve that. So a minus c equals 3. Let's eliminate my c by just adding these together. So I get 3a is equal to 15. So therefore a is equal to 5. Next piece is to find out b. Well, it's easy to find b when a is 5. They have to add to be 0. So I get 5 plus b equals 0. So b is negative 5. And then my c, using my green equation, that second equation there, substituting in my a and b. So I get 5 minus a negative 5 plus c equals 12. So I get 10 plus c equals 12. And I get c is equal to 2. Last piece here is just to add and put everything together here. So my partial fraction, I'm going to have 5 over, that's my a value, over x minus 1 plus my b, which is negative 5, x plus c over my irreducible quadratic, x squared plus x plus 1, and that was all equal to the 12x plus 3 over x minus 1 times the quantity x squared plus x plus 1. So I've decomposed this function to make the sum of two easier functions. All right, so we have a repeated non-irreducible or an irreducible quadratic here. So that means I need to break this in and decompose this fraction as ax plus b over, well, because this is squared, I got to do it first. So if it's not squared, okay, plus the cx plus d over, when it is squared, as its potential partial fractions. Okay, so like we've done before, let's go ahead and multiply both sides out from our denominator. So I'm going to multiply this whole side by x squared plus 5 squared. In the scope of this course, we're not going to see too many more complicated than this, because as you can see, we have 4 variables. Solving a 4-system equation, typically things should fall out pretty easily so that you can solve them out. So here, as we multiply it out, we're going to get 2x cubed plus 2x squared from here, and this is equal to, so when we distribute this to that term, one of the x squared plus 5's cancel out, but I'm still left with ax plus b on top, times one of those, which is going to be x squared plus 5. Plus, well, the nice thing is the denominator's completely canceled out, and I'm just left with cx plus d. Again, I'm going to distribute this out, so I'm going to get ax cubed plus 5 times ax plus bx squared plus 5b and just plus cx plus d. So let's try and group our cubics here. Well, the nice thing about cubics is there's only one of them. So I have ax cubed. Well, let's group our squares. Well, nice thing about squares, I only have one squared term. And then I got to group my linear terms together. So I have that term and then that term. So if I factor that out, that's going to be a plus 5a plus c all times x plus, and then all I have left are my constants. So 5b plus d. Okay, so if this, let's go ahead and make this b blue. Okay, my x squared. So notice, if I know that this is all equal to 2x cubed plus 2x squared, some things are just going to be straightforward. So the only cubed term is ax cubed, and so a must be equal to 2, because I only have that one term there. Next is my squared terms. Well, that's my only squared term on the left, only squared term on the right, so by inspection I see that b is equal to 2 as well. So this is working out fairly nice for us. The last piece here is I don't have any red terms over here, so this is plus 0x. So that means this equation must be equal to 0. So I get 0 is equal to 5a plus c. I know what a is. Let's plug it in. So I get equals 5 times 2 plus c equals 0. So I get 0 is equal to 10 plus c. So that forces c to be equal to negative 10. All right. My last piece is my constant term. Well, I don't have any constants terms over on this side, so it's like adding a plus 0 there. So I see that 0 must be equal to 5b plus d. Well, I know what b is, so I can do 5 times 2 plus d is equal to 0. And just like before, I get 0 is equal to 10 plus d. So therefore, d is equal to negative 10. Last step here is just to write our partial fraction decomp out. So then I get, since my a was 2, my b was 2, I get 2x plus 2 over x squared plus 5 plus both negative 10s, so get minus 10 x minus 10 over that irreducible quadratic that was repeated squared. So this is all equal to what it was originally, which was 2x cubed plus 2x squared over x squared plus 5 squared. So we have broken this fraction down and we've decomposed it into these two. That's it for notes tonight. Make sure you highlight any questions you might have and bring them to class tomorrow.